I got 3 trains coming in, and I need to keep these people from all showing up in the same part of the terminal at the same time. And it used to be you couldn't even think of dealing with that. Now it's like from a browser, I can see who's coming, what's coming. I can control access, control when things happen. I can control egress mechanisms. I can change lighting. I can change signage, from my friendly browser. So pretty powerful stuff.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Jim Quancy, and he comes to us from Autodesk, and he's going to be walking us through what a digital twin is, what it could be, and what the future of digital twins might look like. So I really hope you enjoy this conversation. Subscribe if you haven't already, and let's get into the interview. Hi, Jim. Welcome to the podcast. Thanks for taking the time to do this interview with me. Much appreciated. We're going to be talking about digital twins today. But I think before we dive into that conversation, and this is going to be a very new conversation for me, I'm not too well versed in digital twins, so I'm really looking forward to this. Before we dive into all that, can you perhaps just give the listeners a little bit of background, just for context? Who are you? Where do you come from? How do you know about digital twins?
You bet, Dan. My position at Autodesk, a place I've worked for 30 years, is developer advocacy and support. So I have a team of people who work with software developers around the world, system integrators, ISVs, third-party developers, and customers. My team has historically done integration, desktop support, for Revit, AutoCAD, Civil 3D, Inventor, kind of go down the list. But the last 5 years has been very much cloud, web. It's about Autodesk has a Forge platform. It's a cloud web native platform, and dealing with, and at this point, thousands of companies who are building web cloud apps that work with CAD data in some way, shape, or form. It's probably over 100 at this point, partners of ours who we work with, who are building solutions that are digital twins. Some of them call it digital twins. Some of them market what they do as digital twins. Other ones, they don't call it that, but it's pretty much the same.
So the astute listener will have picked up that you're from Autodesk, and obviously, so Autodesk makes products based around computer-aided design, CAD products. This is like traditionally there's been a little bit of rivalry between GIS or geospatial and CAD products, and CAD data, I guess I should say. But we're going to be talking about digital twins, and these two things are going to be, I think we're going to find out later on, are going to be very important inputs to digital twins. So I think we should start off by defining what a digital twin is. So could you walk us through that? What is a digital twin, or what could it be?
Yeah, I mean, a digital twin is a model of the real world in some way, shape, or form, providing some simulation kind of analysis capabilities. A lot of us tend to think of it as a model, but frankly, any kind of simulation, analytical view of the real world, which could be pure data, is in effect part of a digital twin. So there's kind of not one definition, but there's no question that a lot of people, when they think digital twin, they think a model of the real world. But people shouldn't really be limited to that. Digital twins, you could make the case, have been around for a very long time. It's really just this last 2 or 3 years where the expectation of what you get from a digital twin has really expanded to not just a model, not just drawings, but including data feeds, IoT kind of stuff, the ability to build these more sophisticated models of the real world in a computer on the cloud, has changed dramatically this last few years.
So I definitely fall into that camp. When I hear people talk about digital twins, I expect some sort of amazing 3D hologram thing that I can walk into, that I can touch, feel, move things around, that kind of experience. But what you're saying is a digital twin that could also be a numeric model that runs on Excel, for example. It could be, so there's a wide variety of possibilities here.
Yeah, absolutely. And I think that the part that has changed is the ability to make it more intuitive through some kind of graphical representation. Again, whether that's a model, it could be a schematic representation, like maybe of a network, whether that's a water network or an electrical network, or it gets down to a lot of what the digital twin's about is about the end user having an easy way to tell kind of what's happening in the real world and how's the real world performing compared to the analytical view of how it's performing, the simulated view in software, to be able to identify opportunities, identify problems, better ways to operate, or preemptive maintenance, something's amiss, in a very easy, and these days typically from a web browser, which means kind of any device anywhere.
Okay, so I think a lot of the listeners of this podcast, they'll be used to the idea of digital models. And so for geospatial people, that digital model, it could be in a GIS system somewhere. So some 3D or 2D model of the world that somehow, shows features in the real world. They have a geographic location. What kind of model are we talking about here? Does it exist in one piece of software? Is this something that exists only in CAD products? Does it exist in GIS products? Is it a whole nother piece of software? Where do these models exist?
Sure. So a little bit how CAD tends to get involved is the original design, whether it's for a building or a piece of highway or some rail or a machine, was done in CAD. So that creates context, and that would have objects, that would be placements of things like sensors, but the data is sitting in an IoT middleware database. Whether that's a few sensors or hundreds of sensors or thousands of sensors are feeding data. And you've got this data coming, from one of, whether it's AWS, whether it's the Azure Digital Twin, whether it's somebody like Honeywell, Johnson Controls, Siemens, ABB. They all have their digital twin middleware, and it gets back to this IoT thing again. And then that model, again, whether it's a machine or a piece of infrastructure or a building, is also used as a user interface to present that information back to the user in an intuitive way, right? They can, and again, whether it's 2D or 3D, showing data kind of in context. I mean, that's really what brings the digital twin together. Don't think of it though as the data is all in one place. That is generally not what happens. You may have that 3D model that's being managed in, let's say, some Autodesk technology. You've got the IoT sensor feed data that actually could be coming from several different places, because some of it may be security, coming out of a security system that comes from one company. Some of it may be machine control systems or traffic control systems. You could absolutely have 4 or 5 different systems all feeding data and presenting it as in a digital twin environment. Again, whether it's a 2D graphic, a schematic, or a 3D model of a piece of infrastructure. You mentioned geospatial. Absolutely, some of this data is coming out of your GIS system, such as from Esri. And again, this idea of federating data is pretty important, because the world's it's too big a place to think you're going to have all your data in one place.
So I think that's really important for the listeners to understand, and also for myself. This is not something that's going to sit locally on my machine like a GIS database. It's not sitting locally on my machine. It's dragging in sensor data from Internet of Things sensors. We're pulling in CAD data, we're pulling in GIS data, and we're taking it into a centralized database. And what's happening to it from there? It's heading out into the world as what?
Well, again, it's being presented in your digital twin system. Will present that information in some intuitive way on a web page. Again, with appropriate data, depending on what you're managing. Whether that's thematic color coding, whether that's actual data. I mean, most of us have been watching some really interesting work around COVID, right? What's going on with COVID cases down to the census tract. That's a digital twin of kind of the COVID virus in action across the country. And that data is coming out of many different systems.
Yeah, that's a really good example. It's a really, really good way of looking at it. I hadn't thought about that before. Okay, so we've got tons of input here. Again, we've got some sensor data, we've got some CAD data, we've got some GIS, geospatial data going into the system there. And one of the things we talked about before, we said a digital twin is basically somewhere where some sort of numeric modeling simulation can happen. Where is that happening? Is that happening in the middleware, or is something else like looking into the database from there and doing the modeling? Or is it there's something that happens in the middleware itself?
It's kind of yes, yes, and both. This is very much web cloud mashup, depending on the problem you're trying to solve, depending on how you want to present information. It's not one. There's no one answer to this. Do most of the digital twin, IoT middleware companies have kind of analytical suites and tools that will allow you to analyze the information? They absolutely do. Do you get customers who say, I want to use Power BI from Microsoft because, I know how to custom tailor that and I can build that around some other enterprise systems I have? Yeah, that kind of thing absolutely happens. Do you get open source tools for doing those kind of analytics? Oh, yeah. Do you get companies like, I don't know, Splunk and the sort who do those kind of analytics? Absolutely. So yeah, this is definitely an environment where there's lots of tools, lots of choices. The key thing is if you go back several years, this stuff was hard to do. If somebody said, "Hey, I need to tie these 7 pieces together," some would say, "Oh, it's going to cost a lot of money, and it sounds risky." And using standard web technologies, using REST-based interfaces, your ability to put these pieces together at web speed. When you ask someone, when you want to get a website built, you expect, to see something in a couple weeks. You expect something to go live in a couple months, and you can absolutely do that. You can build out, a basic digital twin by grabbing the pieces, staying focused on what's the experience you want to deliver. And again, when I say experience, that tends to be about help someone make a better decision, help someone. And a better decision could be, they know they need to make a decision, or a better decision could be, hey, I need to get your attention. There's something going on here, and you should go look at what's happening here because of temperature, moisture, vibration. There's something suspicious, and you need to go take a look. In a very easy way. Again, you go to a web page and you see what's happening, and you get a notification by text or Slack or whatever communication mechanism you want to use. And the funny part is it really is whatever kind of communication mechanism you want to use, because these days, using standard cloud technologies, it is really easy to tie these things together.
Okay, so I guess one of the reasons why I'm having a hard time pinning you down to a really precise definition of what this is because it could be so many things. It sounds like you're pulling in data from all different data sources, sticking it into some sort of centralized database, and doing some simulation from there. And it feels like it's wide open. You could use a bunch of different technologies to this, a bunch of different inputs, and output it in a bunch of different ways. And I think probably another reason why it's difficult to really pin down what it is because I guess it really depends on the problem you're solving. Do you think that's a correct assumption?
Absolutely. So just to give you an example, so we have partners doing digital twins of factories. We have partners doing digital twins for machines, and it may be for their customers' machines. We have a few partners building digital twins for highway. In Europe, there's a couple of the rail systems that are building digital twins. And it's like, well, how do they do that? Well, a lot of them are, well, let's do a digital twin of the stations first. And then we're going to build out for all the rail infrastructure, let's say, or the water systems, or it just goes on and on and on. Now, again, the interesting thing that I think anybody who's been talking to customers about digital twins is customers who are kind of dabbling, like they've heard about it, it looks interesting. This last 2 months, a lot of these customers are like, we need to do it now. I've been asking enough questions. We've been doing the research. We can't have people traveling around in this COVID environment. The faster we can get a digital twin up, the faster we can operate our business while minimizing the need for people to travel, minimizing the need to put people out in the field. This is important. We need to do it now. So there's clearly a change in velocity in this area in this last 2 months.
Yeah, I could definitely imagine that being the case. I think that was really interesting what you said there. It made me think of people modeling a business, like the connectivity in a business. Where are people traveling? How are they getting there? How are they getting back? And modeling that network there. But I would like, and I think that's a really interesting thought, really really interesting concept. But if we could perhaps hold this to physical infrastructure for the time being, and you mentioned before about in Europe people modeling railway systems. So they start with the station, perhaps, and then they model the network. Could you perhaps give the listeners an idea of what kind of problems you could solve once you have a digital twin of a railway, for example, of this physical infrastructure? What kind of modeling could we do? What kind of tests or simulations could we run?
Yeah, and be careful on the simulation side, because What's different is because simulations have been around forever. It's about simulations and analytics based on real-time data right now. So you've got your model of how things should run, and you're getting this real-time data telling you how it is running. And that allows you to go, something's amiss. This piece of machinery is supposed to be running at a temperature range between, 120 and 140 degrees C, and it's running at 150. What's that about? Now, nobody said anything. Machine's not down, but something's amiss. Let me go check vibration. Maybe we got a bearing problem there. Or, we're in a rail station and we're actually tracking the number of, people movements. And something's amiss. There's too many people going in and not enough people going out. So what is that about? Well, as part of my digital twin system, I've got closed circuit TV. Let me go look at closed circuit TV in that station, because of, hey, there's something amiss here. Let me go find out. Or I've had a sensor go off saying there's a temperature spike. Is there a fire in a machine room in a train station? Like, I can spot that from halfway across the country before anybody at the train station even knows that's going on. And I can start to do things. So if my IoT system is connected up to machinery, and this is real, you actually see this in like airports. This wouldn't be unusual. I can, from my desk, turn off the ventilation system. I don't want to feed fresh air to a fire. I want to unlock all the egress doors, turn on all the emergency lighting, get the 3 closed circuit cameras in that area of the terminal, and do this all from just a web page. And then maybe I need to, reach out to some security people to, go do something.
Okay, so I obviously completely missed that real time component of this. I just assumed that we were feeding in data, and as long as we had data that was relevant, not necessarily real time, but relevant, we could do our simulation and modeling. But after what you just said there, I'm a little bit in doubt now. Can we talk about digital twins without talking about the Internet of Things?
I don't think it's an interesting conversation without the IoT component of it. Yeah, because it really is about getting that data. Now, I said real time, sometimes it's almost real time. So let's go back to the way things were, let's say before IoT was really there, before cheap, widespread sensors and the way to deal with large amounts of data pouring in. The data was there, but you'd have some analyst type who would spend 3 months, 6 months, 9 months, 2 years, researching data, looking at trends, doing analysis, and trying to use that to do better decision making. Maybe it was better decision making about capital investments or, the safest way to design an intersection. But those things were happening at months and years timeframes. Now you're getting data. It's like it may be real time, and if it's an electrical network, it's pretty damn close to real time. If it's a traffic thing, it may be about, I can make a decision in minutes. If it's a rail thing, it may be, yeah, I need to, rejigger the schedule for, the trains that are coming into the station because I don't want 5 trains showing up at the same time because then social distancing will be impossible with that many people coming in. So let me slow some trains down so they don't all show up at the same time. Sort of real time, not quite, close. Yeah, and I think it's going to get real interesting when, again, I'll keep going down this train station thread. I got 3 trains coming in and I need to keep these people from all showing up in the same part of the terminal at the same time. And it used to be you couldn't even think of dealing with that. Now it's like from a browser, I can see who's coming, what's coming. I can control access, control when things happen. I can control egress mechanisms. I can change lighting. I can change signage, from my friendly browser. So pretty powerful stuff, to say the least.
Yeah, yeah, absolutely. So I'm just trying to put this all together in my mind here. And what I've sort of come up with so far, digital twins and Internet of Things, like you said, I would tend to agree with you now that, I mean, the conversation is so much more interesting when you add those things together. And I think once you start talking about the connectivity that we have today, the processing power that we have available, and I guess if you had to draw a funnel, this is all the things that are going to funnel the idea of smart cities. This is going to be what smart cities are built on.
Absolutely, absolutely. And some of this, the interesting part is it's you get these different scales. So we get kind of land scale, seeing what's happening. Again, where's the COVID hotspot on certain census tracts, that kind of thing. Then you get the city the neighborhood, you get the building scale, building information modeling, you get machine scale, transformers, switchgear, railroad cars, and the sensors and the data coming at all those levels. Now you could sit there and go, this is pretty intimidating, complex, big systems. And the thing is, you know what? It's not, because this is very much, again, web cloud, using web technologies. You can put together specific kind of views. I tend to call them single panes of glass of the appropriate data for someone who needs to control things and make decisions so that things happen smoothly, correctly, safely.
So this gets right back to that conversation we had right at the start of this interview, where we talked about the different complexity levels of this digital twin. It could be, everything from running a numerical whatever simulation test in an Excel spreadsheet to some very complex systems. It could be as big or as small as you want it to be. At least that's the way it sounds to me. And I'm thinking that a lot of the data we need to do this, except when we start talking about real-time data, Internet of Things feeds coming in, I'm assuming people have access to this data already. So it's a matter of channeling it into the right middleware and then deciding, well, what problem am I going to solve today?
Dan, I would say, what problem do I solve today is the first question you ask. Where's my biggest problems? Or where's the biggest opportunities? Is it safety related? Is it operations and maintenance efficiency? Is it energy usage, kind of sustainability? Is it, and a popular one for me is, in the last weeks, months, years, when did you make some decisions that you regret or that you were like, oh, that was not the right answer? Where has there been pain? And by having the visibility of data and presented in a way that's very intuitive, and that's where that digital twin thing comes in. It's about presenting what would otherwise be huge flows of data that's hard for anybody to understand, but presenting it in the context of again, the machine, the building, the city, so that it's very quick and easy for kind of mere humans to understand what's happening and to react to it quickly. Again, I'll use the example historically. In big organizations, you'd have some analyst or analytical person who would disappear for weeks, months, grinding through data to come to you and make a recommendation. Well, I want to make a decision now based on the data, not come back to me in 3 months.
Okay, so I'm all in on this digital twin thing. It sounds like a great idea. It sounds like the future. And I want to move off and talk about what the future of this might look like in just a minute, although I feel we've touched on it. But I want to look at it in a little bit more depth in just a minute. But first, I want to ask, is there any situation where you think a digital twin is not the right solution? Where should we not be deploying this kind of technology?
The term's gotten a bit overloaded. It's kind of a bit faddish. And I think it's the model view of things. I do think people need to realize there are some things that you just need the right data to make a decision in a more timely manner than you've had in the past. And that information may literally just be some data. It could literally just be, a web page that's telling me the temperature or something, and I don't need anything more than that. So, don't let the idea of a digital twin and a big model kind of get in the way of what's the problem you're trying to solve. So sometimes it'll be data on a page, and maybe the numbers flashing red get my attention. Sometimes it'll be some diagrammatic thing, a P&ID diagram, an electrical or a sewer network kind of thing. And sometimes it's a model in terms of a 3D model, because that's the easiest, most intuitive way to understand what is happening in a system. So you can make a decision. We need to go do something, and we need to turn a valve on or off. We need to shut some process down. We need to plan preventive maintenance for the day after tomorrow. Or, we've been watching the vibration on this bridge for the last 6 months, and it's gone from a gradual increase to what's looking like a logarithmic increase, and something bad's going to happen. We need to shut this bridge down right now. What I've seen some people do is, oh, it's going to take all this time and effort and money to build some 3D model and trying to maintain this model, and because of that, I'm not going to do anything. The answer is no. You can start small, you can start limited, you can kind of build up.
So this feels almost like software development, where you move forward in these small incremental steps, and you check, does this work? Does this still make sense? Okay, we build on top of it. We move on, but it's always these small incremental steps. Are we adding value? Yes, no. okay, we continue, instead of that waterfall model where it's like, okay, this is the project, we're going to walk in this direction for 3 years and then we're going to look. So I really like that idea of just sort of what is the smallest or the minimum viable product here, I guess you could call it. What's the thing that we could do that's going to add value today, and then how can we build on it later on? At least that's what I'm hearing you say.
Absolutely, Dan. And I'll say a bit more. So that, agile versus waterfall, absolutely agile. I'd also tell people, if this is all new to them, think of something easy, something a bit of pain, something that's a nuisance. Build your digital twin for just that, because when you're in kindergarten or you're in first grade, you can't be there talking about calculus because you don't have a foundation enough to have a good conversation even. So do some simple agile, get some benefit, spend a few months solving a few problems, and then you can sit back and go, now you can put together your vision, your big vision. I call it your 2 or 3 year vision. You're still going to go after it agile. You're still going to go after it a bit of piece at a time. But learn a little first so you're smart enough to know what to aspire to, enough to know what your vision is, and then start going after that vision in an agile way. And anybody who's done this for a while, done kind of big projects, we've all had that experience where a year into a big vision, our vision actually shifts because we've gotten smarter, we've learned more, or the environment shifts. I mean, think of, again, what are we all going through today with COVID? The environment shifted. And what's that mean to my vision, my strategy? Though again, it is interesting. A lot of these digital twin visions are getting accelerated because what's happening in the world today.
Yeah, but it's all about like doing something and then making a decision based on the new data that you've acquired, the new experiences that you've got, right? So, and for me at least, that's what agile means. So I do something, I make a decision, I move forward, I stop, I look around. Okay, based on the new data I've got now that I'm standing in a different place, I make a new decision, and it may turn out to be that I made the wrong decision before, so I adjust and I move on from there. So I promised the listeners just before that we'd move on and talk about the future. And during a previous conversation, you talked about this really interesting example. I'm not sure if it was a thought experiment or something that actually happened, but it had something to do with my homeland, New Zealand. And a wee while ago, they had a massive earthquake there. And you were talking about the potential for deploying digital twins in that kind of environment. Could you say a little bit more about that?
Sure, love to, Dan. And this is a good one, and some of it's because yes, there was this. In fact, there's been two decent-sized earthquakes in New Zealand in the last few years. But I also live in San Francisco, and I've been through two pretty big earthquakes where people had to run out of buildings and weren't allowed back in. So, during an earthquake, buildings shake, and some of them get damaged during that shaking. What has to happen is there has to be inspections of the buildings to decide, are they safe or are they not safe for people to stay in. And here in the United States, they call them a building gets after a big quake gets red tagged, which means no one's allowed back in. Like full stop, you can't go back in. Don't care if you want to get your wallet, your passport, you're not allowed back in. Yellow tagged, which means you can go in for 10 minutes, grab what you need, but then you're out. You can't live there. And when there's a big earthquake, someone has to decide what buildings are safe and not safe. And this can take a day or two or three, where you've got people in a very chaotic state not knowing if where they are is safe or not. And if you run the local city, right? So whether you're police, fire department, building department, you're sitting there with not enough people that basically have to inspect hundreds or thousands of buildings as quickly as you can and safely. And this is hard. Cities will tell you that have been through big earthquakes. It's weeks and weeks later before really people know what's safe, what's not, and people know, what they need to do next. So what's being done, this is actually being done in some cities, right? Is you add sensors, accelerometers, basically the same motion sensors we all have in our phones. And you put them in a building and it's, connected to the internet. And during a quake, you're measuring that sensor output. You can see how a building shakes. And I don't know how many people know this, but even no earthquake at all, buildings are moving. Whether it's the wind, whether it's people, whether it's a truck that drives by, you can measure that vibration. You can characterize how that building shakes. And during the quake, you can watch how that building shakes and you can identify there's a building that's been damaged because when it gets damaged, the way it shakes, the way the vibrations work through change. So what you can do is hundreds, thousands of sensors across lots of buildings. And as an earthquake happens, you can hey, a little bit of machine learning, you can identify buildings that are suspect or that are clearly something's wrong. So you can have on a map of the city showing all the buildings that look okay, their vibration characteristic hasn't changed at all, that look suspect, something happened the way it vibrated, the way that building moved, that makes it potentially dangerous, or there's absolutely something wrong with this building. It is not shaking the same, whether it's a structural problem, whatever it may be. So literally, within a minute or two of an earthquake, the police, fire department, building planning department, all those emergency people can tell which buildings to go to first. Go there first. That's where they're most likely a problem. Because otherwise they're sitting there waiting for phone calls from people in distress, phone calls, people who are scared. And after a big quake, there are lots of phone calls, and the networks get totally clogged with everything from I can't find my dog to my building is falling down. And this way, in a very analytical way, you can send the right resources to the right buildings right away. Yes, you're saving lives that first day or two kind of after a quake, but it also helps you kind of reopen the city quickly and efficiently because you know where the problems are, which areas are good and can wait for to get an inspection 3 weeks later. Hey, that's just fine. And the interesting thing is this is not hard. I mean, we're talking under $100 device in each building connected to the internet, whether it's using a cellular connection or some Wi-Fi connection, feeding data to some centralized database and presenting that information in a very analytical way in near real time.
So I can definitely see that. I can definitely see this, so some sort of machine learning in the background, sucking in all that information, how the buildings move. And then I could also see, like, if you had a really accurate model of that building, you could apply that shaking to an individual building, or at least a set of buildings. I know all the buildings in the area that have these same characteristics. I'm going to apply a certain amount of vibration to them over a certain amount of time and then come up with a really accurate answer. Can they, are they still structurally sound after that? But I think the beautiful thing about this example is that it's very tangible, and you could start very small. You could say, okay, everything that shook, you are now red. Everything that shook so much or a little bit less, you are yellow, and so on and so forth. But then you could also scale it up as your model improves. Hey, Jim, I want to thank you for walking us through that example. I want to thank you for your insights into digital twins and just explaining the whole concept to us. I've learned a lot. I hope the listeners have learned a lot as well. And just before I let you go, perhaps you could let me know where we can go to reach out to you if we have any questions. Is there some sort of website or contact information you can give us so we can follow up with you?
You bet, Daniel. These days, I tell everybody just Google it. If you Google Jim Quancy, you're going to find me. YouTube, Twitter, LinkedIn. Happy to talk with people. I have these conversations with our customers and our partners. I mean, literally every day. Your audience is a more educated technical audience. It's not the whole world, so I'm not worried about being flooded. Just reach out. Happy to chat. Happy to share. My team works with lots of partners who have deep expertise in different areas of this digital twin topic.
Thanks again, Jim. Thank you for your time. Thank you for your insights. I really appreciate it.
Yeah, thank you, Daniel. It's a pleasure.
So I really hope that conversation with Jim has helped sort of remove some of the mystery that surrounds digital twins. It certainly has for me, and I hope you understand, a little bit more about the term. Perhaps it is a little bit loaded, like what Jim was alluding to there at one stage during the conversation. But I think the concept is really interesting, and I think these kinds of things, I'm pretty sure we're going to see more of them, and I think we're going to see some really interesting use cases for digital twins in the future. And that's it for another episode of the Mapscaping Podcast. My name is Daniel. It's a pleasure being your host again this week. Thank you so much for tuning in. You are more than welcome to join our email mailing list. This is where I send out a weekly newsletter with all the resources from interviews like this one to you via email. And if that's something you might be interested in, check it out at mapscaping.com/podcast. There's a couple of different options there. Choose whichever one that suits you. You can unsubscribe at any time if it's not delivering value. Not a problem. No hard feelings from my side. As always, you are more than welcome to reach out to me on social media. I'd love to hear from you, or connect with me on LinkedIn. Just search for Mapscaping Podcast Host. There's only one of them. That's me. I'm easy to find. Okay, thanks again. See you next week. Bye.